quiz 3 key here. Label the chiral centers for the molecule below. So we were looking for things, atoms that were sp3 hybridized and bonded to 4 different things. That's right, sp3, 4 different things. Had a couple troubles. So these 4 obviously are the ones that are correct. A lot of folks labeled the nitrogens, which are incorrect. They're not bonded to 4 different things. And a lot of other folks labeled this one, again, 2 methyls are the same, so they're not different. So it's just these 3, 4. And of course, this molecule is actually the latest antiviral drug for COVID that's been developed. Next one, number 2. Number all the atoms except the H's. Add lone pairs, add formal charges to give the mechanism. A lot of folks forgot to number at all. And I was pretty generous. Make sure you number a little bit at least on the thing that's reacting. Add lone pairs, of course. Our charges. Formal charges, minus charge there, minus charge on the bromine. Then give the mechanism. This is an elimination. It's an E2 elimination, even though we might not have known this at the time, but we could say bonds broken, bonds formed. So we notice carbon 3 has 2 hydrogens here. On the product, it only has 1. We know we need to make an OH bond, so these electrons are going to react with the hydrogen. That's going to form an OH bond. These 2 electrons are going to move to between 2 and 3. That's going to form a new pi bond. And at the same time, the carbon bromine sigma bond is going to break, and those 2 electrons are going to go to the bromine to give the product. Plus 2 for each arrow as well. Most folks did well in this one, even though I have it labeled incorrectly. This is, of course, a Z alkene. Sorry about that. Z alkene. The bromine and the fluorine are on the Z same side based on their rankings. Carbon's a tie, but then carbon to carbon, fluorine wins. Carbon to carbon's a tie. Carbon still a tie. But now this is carbon, this is bromine, so this is highest rank, so it should be a Z alkene. This one, make sure people needed to show, right? We were told it's S, so you need to show the rankings 1, 2, 3, and 4, and then draw in the wedges and hatches. One thing I saw lots of folks do is not put the wedges and hatches right next to each other. The wedge and the hatch need to be next to each other. Wedge and hatch next to each other. That's the key. Lots of ways you could have drawn it. Make sure it's S. Use your molecules, red, white, blue, all those kind of things. So number 5, I goofed this up, so everybody got the points for this, but explain why the nitrogen in the molecule on the left below is less reactive. I meant to have it be less, the word be less reactive there. This is actually less reactive, and the reason why it's less reactive is because this nitrogen's lone pair can do resonance, and if it's doing resonance, it's not going to be as reactive as something that can't do resonance. So this one is less reactive because it's stabilized by resonance, so it makes it less reactive. Having resonance makes things less reactive. So please be sure to look that over. Last one, a couple of folks had some confusion points here. Kinetic and thermodynamic products. The thermodynamic product just means the most stable product, so that's B. The kinetic product means the product that came from the lowest activation energy, so that's also B. And the endothermic just means the product that was higher in energy than the starting material, so that's endothermic. So a lot of folks kind of got the kinetic messed up. It just comes from the lowest hill. So sometimes one product can be both kinetic and thermodynamic products. That's possible.